Thanks for attending this session. So many people today. Little bit early, I think. Today we'll talk about Postgres deployment in a containerized environment context. We'll see two kinds of container technology, LXC and Docker, and all this stuff deployed in OpenSVC store. So we'll start by introducing the use case that led us to build this kind of solution. A few words about technologies we will see during this presentation. So LXC, Docker, and OpenSVC. And then we will move on a screencasted demonstration of the product and what it does. So first of all, the use case. The needs come from a French user, which have a project of building a hosting infrastructure for 350 instance different database of Postgres. So very sensitive data, and they target around 10 nodes. This kind of setup. Multiple clusters, so the nodes are big nodes, big CPU count and big memory size. They wanted a production-ready solution, something that works for a long time and which is ready for DRP also. And they have an expectation about third-side arbitration in care of the split of the two main data centers. Okay, so those people are using stretch SAM, and does it work? Sorry. Come back. So those people are using stretch SAM over data centers with high-end arrays. They expect synchronous data replication also, and for the DB part, DB18 was attached to manage the stuff like they do with a VM environment, like in VMware. So they would like something that they can SSH into. That's why LXC was the best option according to us. So to summarize, something manageable, reliable, and providing automation features. Also, they wanted to be able to cap resources, limit CPU, limit memory usage. That's the global picture we will discuss on. Let's move on to technology. A few words about LXC containers. So LXC, what are this kind of technology? First of all, it's now more than 10 years old. It's kind of virtual machine virtualization technology. But it does not emulate any hardware components. It just shares the hyper or kernel view of the components, but with its own dedicated OS, operating system instance, meaning you can have an Ubuntu running CentOS 7 or the reverse, something like that. And its own package database and dedicated also network stack in the LXC container. Okay. Of course, relying on ansible group and namespaces on the Linux kernel to be able to do resource capping and different PID namespace PID. For people who may know this technology, it's very similar to Solaris and BSD-Jails. On the right, I just put a small screenshot of an LXC container. It's a PS command on the hypervisor. So we can see here the init process and all the traditional processes we have on a dynamic system. So one container here and another one here. Okay. Next, a few words about Docker container. I think all of you already heard about that and played with that. So just a few words. It's a way of delivering application with some standards. Back together dependencies and application, and we ship an image. So this allows application isolation. And like LXC, it's also sharing the operating system kernel, rely also on namespace groups for also scaping in different usage, like network and bid numbering inside the containers. The advantage is that we don't have not another OS layer to maintain, to patch, and just have to have the Docker stack available in the system, and you can pull the image, instantiate the image, and run the Docker containers. So it's fast, fastable, and since for 5 years now, we see a huge usage, growing usage of these technologies. Interesting to try. So we have those two kinds of technologies for containerization, LXC and Docker. We will see those to achieve the same goal, which is the use case we saw in the first slide. Now OpenSVC, a few words about it. What is OpenSVC? Basically, it can be summarized as an open source project that manages either traditional or containerized application, or both at the same time in the cluster, and that across multiple hosts. So we are a kind of orchestrator. If you know, we can be compared to HashiCorp or Kubernetes, Mesos, things like that. But we are not only dealing with container. We are also capable of dealing with traditional application, legacy application. We are supported on multiple operating system developed in Python language. So basically we have a daemon and a command set associated to request action to this daemon. We can be installed in any kind of host technology, Diameter, VM Cloud, whatever, across multiple data center, and we are able to build also intercontinental cluster. We have a service-oriented approach since the beginning. Okay. And we also have a web portal to centralize all the information for the services. So a little bit more description. We support multiple kinds of service topology, from just a quick systemd alternative when you want to just deploy a simple application on the system, to more complex services on the cluster. We will see that later on another slide. Basically, a service is an object that is used to group resources into. So we do some legal with IPs, disk, volume groups, pools, application launchers, file system, whatever, containers. So you build your application, and with this service object you have some methods to manage it. So I just start, stop it, relocate to other nodes. So day-to-day, easy to use. We also have more modern features integrated with our product. First, we pilot the service orchestration by target state. So you request the daemon to have this service started, and the daemon deal with reaching the service to the target state. we have a lot of experience in production. So we have lots of supported driver in cluster communication. So we are able to be installed in every data center we have. All these people manage to build cluster using some outbit communications. So unicast, multicast, shared disk, and third-site relay through IP. And we have also arbitration algorithm in case of split brain when nodes are just in a split situation. We also provide in our cluster some feature to make automation easy. Native REST API, provisioning and provisioning feature based on templates. We will see that later. And facility to do some remote management. We also have a deep container integration. We support multiple kinds of container, like I said, Solar Jones, BSDJs, KVM, Docker, and more recently, Podman, which is the Red Hat implementation. Docker without Docker, which is Podman. What's interesting, we also have backend networks, private networks in the backend of our cluster, with an integrated DNS management. So service you deploy are automatically written the DNS configuration. And we also have ready to use ingress gateway, like Envoy, mainly to provide access to the backend services. So ingress gateway holds public IP and holds client connection and route of the connection to the backend. Okay. So we can be seen as a kind of bridge application, bridge to infrastructure to on the one side be able to hold kind of traditional application with long life cycle like database that many customers already still have in production today. We provide high availability on this kind of application. And on the other hand, we provide facility for more modern approach with CI/CD and short lifecycle services. I deploy my service, I destroy it, and I redeploy with dynamic scaling facility and things like that. A few words about service topology support in cluster. Classical for active-passive cluster. Flex service that we call when using active-active instance. And we have a more modern service which is called scaler, that you just give target. I want at least 2 instances, and I can scale up to 10 instances. And you have facility to trigger the auto-scaling of the application. That's all for OpenSVC introduction. Now let's move on to the demo part, which is a screencast. If you're interested in going deeper, I created a repo with the file in the screencast after, if you want to have a look. So just to remind the first slide, we have the starting point, the use case, which is the Postgres deployment for a French company. We will build a template and then redeploy it. So, first of all, a few words about that, if you don't mind. So, a few words about what is displayed on the screen. So it's a Tmux session, okay, split screen. So 3 shells running in parallel. on the right part, we have some commands which are passed to the cluster. Here, at the top left, we have a command which summarizes the overall cluster situation. Here. And here, at the bottom left, we have kind of tail on the service log file. Okay, so it's a real use case. It's not live demo, of course, because it's a screencast, a video screencast. But the commands are injected actually by our CI automation robot. When we push patch to the code, we run a set of scenario into the cluster to check that we do not inject regression. It's one of the scenarios: deploy LXC container, deploy Docker containers, something like that. So I did a fast forward in the video just to show you when we are in a position of using an already made template. So here I point a template, a service template, and I just ask my cluster create a service named SVC LXC1 using this template, and I pass some variables to my template. Okay. So once I do that, I have a new instance, a new service instance deployed in the cluster based on the template. It could be an HTTP URL on GitHub pointing an external repository. It's also supported. And once you have done that, you can use your print status command to ask the cluster, tell me what you know about the current status of the resources. So here you can see a stack of different kind of resources for this service. So we have an IP, we have some disks, we have some file system. Here we have an LXC container and some synchronization about data. Okay, so this service is created in the cluster, but the P flag here means that they are not provisioned. They are not currently exist on the system. So here I will trigger the provision of the service. So as it's a test environment, it's a bit long. That's why I need to fast forward to avoid losing too many time. So the cluster is currently provisioning the service, as you can see here. Okay, so the service LXC1 is currently being provisioned on node demo 1, first node, second node. Okay. And the provisioning task means build all the resources for the service and start the service. So basically what we see in the log is the ZFS pool creation, file system creation, populating file system with the LXC root file system, the container inside. Here we inject network configuration in the container, and we run a post-provision hook, which do some kind of setup, and mainly the most important is running here bootstrapping an ansible playbook, which will do the Postgres setup in the container. Okay. So we won't wait for the playbook to run. So we are in the logs here. Steps passing. Okay. Here we reach the final provisioning state, and we can see in the cluster summary on the top left that the green bullets mean that the service is now up on node demo 1. So at the moment, I have a ready-to-use database, Postgres database on this node. when I issue the in status refresh, I can see all the resources are now up for the service. Here we send a query, a simple query in the database, so we see it's fine. And just to test if everything is okay, we ask the cluster to relocate the service to the other node. So it's currently stopping in node 1, and it will be starting in node 2. And in the cluster logs, we see resources go down on the first node. So we stop the database, we stop the container, and then file system deport the ZFS pool, remove SCSI reservation on the array, and then we do all the stuff on the remaining node. We put the SCSI reservation, we import the ZFS pool, mount all the file system, start the LXC container, and then the database will start also. Here we have this network setup. So the Python agent is injecting network configuration into the LXC network namespace, which is not the same in the hypervisor, of course. Here we have the startup of the database. And then now, here on node demo 2, we see the service is now here on this node, and the database query is fine, is working fine. Okay. Here I run a kind of admin task. I had a task which is called dbdump, which is a dump, pg dump of my database. Why it is useful is just to attach with the service all the admin tasks I have with it. When you move the service to other nodes, all the admin tasks are moving with the service. It avoids setups like production nodes have a correct cron tab, and when we move on the DRP nodes, the cron tab is no more correct and nothing is working as expected. It's the way we avoid such problems. And we have triggers in such a task object to make the database in a correct state to be dumped on disks. Okay, just a few words. As I said, we started from the point where the template was ready on the cluster, and the cluster was running fine. Just a few words on how we deploy an OpenSVC cluster. Imagine we have just built 2 nodes at the beginning. We basically install a simple package. So a ptget install of the Debian package. Ubuntu 18 for this demo. So currently installing the package and starting the daemon. And then the stuff will be okay on the top left. So here the daemon is started on the first node. Okay, and basically we have built a 1-node cluster, and we are ready to associate another node to this cluster. So what we'll do is to install the node agent, the OpenSVC stack on the second node. So same commands. Okay, the package, apt-get install the package on the demo 2. Okay, fast forward a little. Here, I just say on the demo 1, add a unique star bit. This will be the communication path to the other nodes. Okay, it's the way nodes in the cluster exchange their state about their service there. Okay, so I just set up a unique star bit. Here, it's an optional step to name the cluster. So here I named it DataOps, but it's not mandatory. an important step is to read the cluster secret. So node demo1 at installation generated this unique ID, and we need this secret from node demo2 to be able to join the cluster. So as you can see, a simple command giving the secret from node 1, and I said to node demo2, please join node 1 using this secret. And you see here, the cluster is now formed with 2 nodes. So as you can see, 3 commands to build an OpenSVC clusters, which is really easy to do. Currently, it's being deployed across SSH Trust. It's not mandatory, so just forget about that. It will remove soon. It will be removed soon. So next step, as we saw, we did an installation on the fresh cluster, and now we have to deploy our template. So just a few words about that, quickly. First, I have provisioned my public IP for my service. So in this traditional example, I've asked my network team and my DNS team to provide me a DNS record and public IP. I check that my persistent storage is available, so it's actually the case on both nodes. And then I'll start by filling in and creating my template. So here the screencast is injecting template configuration by command line. Please bear in mind that it's something that can be done just by copy-pasting big file when the template is ready to use. Or you can also inject it with a JSON, like a JSON structure or something like that. So we see some parameters in the template. We won't describe every parameter, but I just say that every node in my cluster can run the service. Here are some variables about LXC, network stuff, IP, which bridge network I use to connect my container to. The storage part, how I will name a ZFS pool, and which disk I will use. So all those environment variables can be overloaded at service instantiation. So now we follow up with the storage part. So basically, we add a ZFS pool with some SCSI reservation. It will be mirrored across 2 disks, and we'll use both options to create the. So you add every resource you need in the service. So here at the top we added a new container, LXC container, and then I'll post provisioning a hook, which is very, very complicated, but here is the result at the bottom right. Container type LXC with the file systems created. So here is a reference to dataset and our post-provision hook, which download and apply the ansible playbook. Okay, we follow up with the IP setup, quite classical parameters. Okay, let's fast forward. Here we have the database startup script as an application resource. This sync resource is a ZFS snap resource. The agent embed a scheduler that will trigger, for the example, every 5 minutes, ZFS snap from my database. So it can be useful for recovery point, to have recovery point in the past of the database. And here is the task I show you to dump the raw database with the pgdump command. So now we have built the templates, so it's not something we can do in a few minutes when we start with OpenSVC, but it needs some work, some testing. But once the template is ready, it's very easy. You just create a service, overload environment variables, and as we saw previously in the video, all the stuff is done by the cluster. Okay, so now we're done with this part. Let's move on. Let's move on the Docker part, which is also a small video. It's shorter. So it's the same cluster, same starting point. As you can see here, we still have SVC LXC 1 running on demo 2. Just a few words here. We, in the LXC example, had the traditional approach where I contact network team, I contact storage team to provide storage. Here we provide facility by configuring into the cluster some storage that I can provision into. So here for the test, it's a free NAS array, which is an appliance with a native API. So I filled in a few parameters, a secret. We have secrets also like in Kubernetes for storing passwords and avoid them to be clearly available in the configuration. I deploy the free NAS array with here the endpoint to connect to, and this array will be able to show my cluster LUNs, storage LUNs. To hide complexity on the storage, because DevOps just don't care about that, I create a specific template, which is a volume template, holding a ZFS pool over 2 disks, mirrored also, and with some file systems. And I create a virtual pool in my cluster, relying on this volume template. Okay. And then in my services, I will just ask for a volume in the pool virtual, the virtual pool V1, with a size of 10 gigs, for example. And I just don't know about the underlying storage protection, because it's the cluster admin who did the job with the volume template. But me, as a DevOps, I know I can provision storage in this part, and my data will be kept safely. So same kind of setup with the Docker approach. Variables that we can overload. So here we are at the step where we build the template for PG Docker. So Docker information, network information, a few storage information in the template. And here I have my storage. So I just point a pool, a volume name here, and a size. Now I had a few information about Docker. First container is a very simple Google Docs which have the role of holding the network configuration. As my stack will have multiple containers, the PG container will inherit this network namespace from container 1. It's a convenient way of working when you have multiple containers. One container is responsible for holding the network configuration, and other containers inherit from this one. Same kind of philosophy in Kubernetes orchestrator. Here I had an init container, also a Docker container, which role is to just prepare my file system tree with the expected mount point and directory, and also owners group on the file system. And then I had in my templates the Postgres container. The interesting things here are the environment keywords, which mean that you will expose some variables into the container environment. So the official Postgres image supports those kind of variables, and at containerized instantiation, you will inherit and you will set the DB name like that, where you put your data and what will be the Postgres password. The secret environment here means that to fill in the Postgres password, just have a look at this secret in the OpenSVC cluster. So we will see how to create a secret just after. Basically, the node agent will go encrypt the secret and inject it in the container variable. So never the secret is exposed. Here, a dump task, like I did for LXC, but here is Docker. BG dump running between 8 p.m. and 10 p.m. So here the template is done, and now I follow up with the secret creation. I create the secret, I fill in the secret, which is here the clear text password for the example. And I say just create the key name password and fill in with that. This time in the cluster, the secret is encrypted and stored like that. And of course it is replicated on every node in the cluster. So it's a kind of kebab store in the backend of the cluster, like etcd in Kubernetes, for example. Here I decode the secret just to check I fill in correct information, so it's fine. Now same logic as we saw with LXC, we point a container and we create a new service named svc.1, and we fill in the Docker image, UID, GID, the side of our database where I pick up my storage from, so pool v1, which is my virtual pool. And here, all my resources are summarized. And as they are not provisioned at the moment, of course, all are done. So it's much faster to provision, but I will fast forward to save some time. We have here all the steps: pulling Docker images, instantiating containers. Here we have the Docker Postgres style. So we will reach the available state on node demo 1 for the svc.1 service. Yeah, now it's done. And if I refresh my status for my resources, every resource are up, except if you get one, the init container with its role was just only to prepare file systems. So it did the job, and now it's the normal available. Same kind of request into the database, so it's just working. Here I relocate the service from node 1 to node 2. So we see every command here, stopping the network, stopping the containers. And now we'll start them on node demo 2. Start at the moment, Docker run. Fine, both services are now up on node demo 2. I resend my query in the database, and it's okay. I run my db dump task just for showing. And then we'll simulate a node crash. We'll crash this node, which holds 2 services. Okay. So it's a dirty reboot. We'll see the heartbeats between nodes that will go down here. Okay, so we have some issue in node demo 2. Immediately we have failover happening on node demo 1. Okay. So it's currently being started. Node 2 is already rebooted because its virtual machine is very fast. So reboot is already done. We join the cluster, but services, as they are currently being started in node demo 1, remain on node demo 1 now. Okay, for this failover, failback demonstration. Now we have more services up on the demo 1. So that's all for the video. I hope it was not too dense information for you. Of course, the Postgres use case could be also any other kind of database or application. It's the same philosophy. Once you reach template logic and instances and service method for managing services among nodes, it's the same logic in OpenSVC. Thank you, and it's now over. Any question, maybe? It's okay. Thank you. Have a nice day.